came from Beisan Systems again. I wanted to explain our process here about how we go repairing a board. I think it's about time. We're well into our beta testing, and I have 4 more to build. So right now, I have this already prepped because it's quite loud removing all the components, and the vapor extractor is on half right now. Usually I keep it on full, so it would just be a pain. So you have a CAN bus transistor voltage regulator, power transistors plus positive and negative. So we're going to go ahead and swap those out. And again, they've already been removed. We'll put it in our holding fixture here. I have multiple soldering irons that are required. We have leaded solder. Now I've jumbled it up. Here we go. Okay. And let me get our components here. 5 power transistors and the voltage regulator. Okay, so I guess I should give some reasoning to why exactly we're doing this. So there are multiple issues in this throttle actuator that needed to be addressed. The one that really brought Roger to it, the owner, is the fact that some of these were seeing burnt power transistors, which are these little guys right here. And through some testing, found out that that specific issue is caused because the dust from the motors, it's a sealed unit, it stays inside the motor, and there's a lot of it in there. And we do clean that out, but over time, it basically shorts the circuit out. One of these, or 2, or a pair, or both pairs, or it's all over the place. So we clean the motor, gets rid of that problem, but a secondary issue is the gearing. The gearing, it's a stepper motor, basically stays in the same spot, goes back and forth a little bit over years and years of usage and wears the gears away. So a full product would be to replace the gears and the common electronics that would fail on here. And through testing, initially, obviously, we went after the power transistors. Well, we contacted the company who makes these, which is On Semiconductor, to find out that these are soon not to be available, which we have plenty of them. We purchased tons of them ahead of time. So we have the original OEM components. And we did see the CAN bus transistor every once in a while that would also fail during this surge that would happen. So in every single one, we'll replace it. So speaking to On Semiconductor, we found out that the voltage regulator had been upgraded multiple times to address longevity issues and also power delivery issues as well. That is per On Semiconductor. So we did test just replacing the voltage regulator on a board that worked already. We just replaced the voltage regulator and ran it through a testing jig. And we found out that there was a little bit of difference in the strength of the operation of the unit. So we came to the conclusion that over time, these components that get hammered a lot from this device do tend to get a little bit lazy, if you would. So the feedback so far from customers have been that they're very happy with the actuation of the unit with, again, these components that really take the most brunt and abuse through the usage, the power components. Getting pretty good results here. So anyways, let's go ahead and continue on and start doing a repair. The first one I typically do is the CAN bus transistor. And I want to apologize ahead of time if I'm saying 6,000 times. I'm trying to break myself of that habit, but I'm just starting out in the videos, and sometimes you don't even notice you're doing it. So there we go again. I just said it again. In time. We're using leaded solder. This tends to adhere a little bit better. Typically first do the legs of the transistor, and that will hold it on. Okay, next I'm going to take the voltage regulator. We're not done yet with that, any of these transistors. I'm just getting the legs on, using a little bit of flux to lower the temperature needed so we don't overheat any units, although they can take a little bit of a beating without an issue. Okay, this one's a little bit more difficult. The legs are half the size, but not bad. I'll typically do the outside ones. Just make sure that there's no crossing over from one solder pad to the other, which with the diopter here, I can see that. I think we're at 2.5 magnification on the diopter. We had a higher one, but it was too much. Okay, so that is settled down. Now what I typically do is I'll go back and do the ground, which actually holds it and does all the heat dissipation. And it's got a little flag on the top here, which I'll solder first. It just helps everything flow after. And as you see, the extractor does a good job of pulling all this pretty bad stuff away from you here. So typically you're allowed, with a higher wattage soldering iron, which I'm using here, up to 10 seconds of direct heat. I do count down between 5 to 7 seconds. I watch how it flows, and then you can actually see as it moves along the body from the front to the back. You can see the heat, and you know that it's flowing underneath. Okay, so those two are soldered. The EEPROM, we're going to test right here. I'm going to try to remove the conformal coating off of that manually. I did put some coating remover on it last night to let it soften it up after I removed the components. And we've tried different methods, and it is a tough one. We need to program it. That's why I'm saying all of this. So we'll go ahead and place these power transistors on board here, and as you see, I need all kinds of angles to work with it. And get the old. And what I am doing here is I'm not only setting the position of the transistor, but I'm also allowing enough room to solder the legs and enough room that the solder can actually have a buildup on the top, and underneath it I'm able to get the heavy soldering iron alongside and get the proper amount in there. So okay, let's go ahead and a couple of these are a little bit more difficult because the board does a little bit more wicking away of the heat from a couple of these legs, so I will have to come back and tap it with the larger iron just to make sure that it is, yeah. And I can see it flowing underneath to cover the entire solder pad when I do that, and it's just momentarily. I don't want to obviously overheat it. So we'll go back and now flux there. And this one we need the big boys for. So again, I was just tinning the top of the transistor, give it a second, and then come back and actually let the solder flow underneath it, bond it to the board. Now we're down to the last two. A little bit more flux. Place the last two transistors. Okay, it can be a little tricky sometimes. You like to squirm around. So we'll go ahead and okay. I'm gonna go come back again and tap these with the big iron. Might as well get this one up here too, just for the heck of it. Okay, a little bit more flux on the top of these. I guess I should say the reason I'm tinning the top of them, it reduces the amount of time you're directly holding the iron on this. Instead of taking 8, 9, 10 seconds, you can kind of let it cool off a little bit. These are cool now, and then you can go ahead and apply and maybe do, 5 or 7 seconds, and that's it's just a little safer. I don't like to be on these too much. Okay, so let me pop this out of here and bring it closer to the camera so you can see. Okay. So all those are on. Yeah. Turn this around. There's a specific way this has to go in here. Sometimes these things can be a little difficult. Okay, let me just take a look. And what I'm looking for here is on the voltage regulator. As I said, these legs are much smaller and they're much more close together. So I'm looking to make sure there is a gap in between the pads and the solder covers the entire pad. At the top of the transistor, that there is a well of solder that looks good and it extends underneath. And especially for the feet, that it extends to the entire pad, which there's a couple of these because of the heat sinking going on the board when you initially install them. Sometimes it doesn't cover the entire pad, so that's why I bring back and touch it with a hotter iron. It solves that instantly. And just checking the condition, components around it, everything looks good. There's nothing that's been displaced. So now we need to go over here and see if we can't scrape off this conformal coating. It seems to be coming off pretty easy since we put the stuff on last night. Yeah, if you don't soften it up, it's kind of a pain. And you gotta be real careful. These are half or quarter the size of the smaller ones from the voltage regulator. And the reason this is such a pain is because this component is actually epoxied to the board from the underneath, or the underside rather. So it's just everywhere. We need to program this. That's why we're doing this. We need to check the health of it, and we do that by programming it. We remove the old bad programming that is from when the unit was actuated from the old car. We found out that there's just all kinds of stuff that gets written to this over time that is not applicable anymore with new components on it, so it needs to be removed. And we have a system right here for doing that. Okay, conformal coating remover. We're gonna just give it a cleanup here. Okay. Lastly, alcohol. She's a beauty. Okay, looks like that is free and clear, and we can go ahead and get some programming on that, and I will meet you over at the programmer. Okay, now we're over at the programmer. Just want to make sure you can see. Here's the EEPROM that we just removed the coating off of. We're going to clip it. Beautiful, clips to it very nicely. As you can see, this is blank. We're going to go ahead and do a read. Can we read it? Yes. So this data up top is fine. This data is usually because of tolerance issues that it will write some code to it to let the DME know how to respond to its current condition. Basically, make some changes in the actuation. Okay, so try to erase it first. Okay, read it. Okay, it looks like it's erased. So we'll go ahead and open up a good known default programming profile, and we'll do an auto program. Okay, it was successful. It's a good EEPROM. So what we have here is it wrote to it, and then it read it back to make sure those contents matched, and it does. It's a good EEPROM. So now we have new components, a good tested EEPROM. We can go ahead and put it on the tester in the garage and see how it responds. Thank you very much. I figured I might as well just do the entire process since we programmed it. Let's go ahead and actually show you it working on the jig here. So same board. What I have here is a good throttle connected to the linkage. I have a throttle actuator that's been rebuilt as well with Beisan Systems parts, and this board that was just rebuilt. What we're going to do is I'm going to connect the positive and negative to this board. That's connected directly into the throttle here, positive and negative. I'm going to take the harness connector, plug that in, put that to the side. All the linkage is out of the way. Let's go ahead and start in. They both jiggle to know that they have power. We'll choose bank 1, and I have to move this out of the way so you can see these actuate. 20 seconds. And you'll hear how quiet it is when it opens and closes. It opened already, but when it closes again. Okay, so the actuation test passed. Now, this is just a simple actuation test. What we do now is we're going to put the throttle together. Let me pull one of these right here. We're going to put it with a rebuilt unit. the actual body itself. We'll take that, we'll put it into an actual BMW. We'll use the BMW ISTA tester in that vehicle along with the ICOM connection, and we'll do a proper test. And there's a battery of, obviously, the functional test and there's 16 subtests, and it'll also do a pre-check on it to make sure that everything is running according to our plans here. That there's no errors that come up, check engines, anything like that. So, but yeah, that's all there is to it. Once we get all this testing out of the way, the unit goes out and gets to you, and you should have no issues. Go in the car and enjoy it. Okay, thanks so much.